Okay, so this is our first video that we're doing this year. What's going to happen is, as I explain some stuff here, you're going to just kind of follow along and take some notes on the notes that I gave you. You're going to add to it. You're going to think about what I'm saying, and it's best if you get ahead of me and try some things on your own. So what I'm going to do now is ask you to pause the video, and you're going to read up to this part right here. Okay, so do that now. Okay, so welcome back. We're going to just talk about some of these transformations and review them from geometry. So it is important to understand these as we move into the transformations that we're going to do in Algebra 2. So some vocabulary that we need to remember. We call the image the resulting point or set of points under a transformation, and the pre-image is what you get before you've moved it. So if you remember from last year, we had translations, we had rotations, we had dilations, and we had reflections. Translation, if you had me, we were calling them slides as well. You know, you could slide instead of a translation. We're talking about two directions, by the way. You could slide left or right, or you could slide up or down. And so then there's rotation. In order to define a rotation, you have to specify what point are you rotating about, and then how many degrees in which direction. So this would represent maybe a 90-degree rotation counterclockwise. A reflection, you need a line for which, in reference, you're reflecting about the line or over the line. So that's like a flip. Some students were thinking that as a flip. So those are your three rigid transformations. Okay, and those rigid transformations mean that you don't change the shape of the size or the shape of the object. Dilation is the non-rigid transformation, meaning it keeps its shape but the size changes. So we kind of wanted to note that. All right, so those are the four transformations from geometry. Remember that the pre-image is the point before you move it. We call the image after you move the object, we call it the image. So here's a review of a reflection. Take a second, pause the video, and read these. I would say read up to here. All right, so welcome back. We're going to talk about how to do some reflections. So the key here is an equal distance, okay, on the other side of the line. That line is known, the line is reflection. So we're going to take these shapes and reflect them over the line y equals 0. So the line y equals 0 is actually the x-axis. So if that's our, that is x equals 0. That's right. The line y equals 0 is the x-axis. So we're going to reflect this shape over it. So what I would say is J is 2 units away from our line of reflection, so it's going to show up over there, and that's the image. We're going to call it J prime. Z is right on the line of reflection, so Z prime will stay right where it is. L is 3 units away, so then L prime will be 3 units away on the other side of the line of reflection. Get rid of those lines. So Z prime to L prime. And there we have reflected or flipped our shape over the line y equals 0. Let's reflect this line over, or reflect this shape over the line x equals -2. This is the line x equals -2. And so G is 2 units away, so G prime will be 2 units away on the other side. Y is 3 units away, so Y prime will be 3 units away on the other side. F is also 3 units away from the line of reflection, so F prime will be 3 units away. And there's our reflected object over that line. Again, it's like if we flip it over the line. Let's reflect over the line y equals 1. That's a horizontal line right here, y equals 1. So if we reflect, I'm going to go a little faster on this guy. Now it looks like we're out of space on here because we need to go 1, 2, 3, 4, 5, 6 units to get to B prime. So 1, 2, 3, 4, 5, 6. It's going to end up here. A little more space than we have. That's B prime. This is G prime, and this was T prime. So we didn't have quite enough graph on that, but there we go. Reflect over the line x equals 0. So x equals 0 is the y-axis. So L stays right where it is because it's on the line. Z will be 1, 2, 3, 4 units away. So Z prime will be 4 units away. And then J is 5 units away. So J prime will be 5 units away. All right. And there's our object once we reflect over the line x equals 0. So those are reflections. And here's an example of a reflection. So you can see that this was your pre-image. How do I know that? Because the letters are A, B, and C, and I know this is after you've reflected it. This is the image you get. I know that because of the A prime, B prime, C prime. All right. Let's look at translation. So pause the video for a second here and read this stuff. Okay, welcome back. Again, translations you can think of as a slide. So I can see that each point slid by the same vector. If you remember from geometry, we talked about vectors. Vector has a magnitude and direction. So if I slide every point, I only showed the 3 main points. You also have to remember that every point slide, there's infinite amount of points just on this line. So each one of them slides by the same vector, which means the same distance in the same direction. All right, so let's look at a translation of 5 units down. We're going to move every single point. Like I said, all these infinite points here on this line segment and all the infinite points on this line segment. But all we really need to do is translate the 3 main ones, the 3 vertices, and connect them, and we're translating every point. 5 units down, so A goes down 5. 1, 2, 3, 4, 5, and there is A prime. Is that an I or an L? I don't know. 1, 2, 3, 4, 5. We move it down 5, and J goes down 5. 1, 2, 3, 4, 5. There's J prime. We connect the dots, and we're in essence translating all those infinite points when we draw the line. So that's a translation of 5 units down. We can do a composition of transformations, which means we want to kind of do 2 transformations. So in this case, we're going to translate up and then 3 units right. And that might even be just considered one translation, actually. It's not a composition of 2 because it's only one translation. So we're going to go each point 2 units up and then 3 units right. That's G prime. T goes 2 units up and 3 units right. There's T prime. 2 units up. B goes 2 up and 3 right. There's B prime. So yeah, this is considered one translation, and it would move by that vector, and we can figure out how far it went if we did Pythagorean theorem. Just some stuff to remind you of from last year. And that's our new object, G prime, T prime, B prime. All right, so there's a translation. And again, that's a rigid transformation. Now let's look at some dilations. Those are non-rigid transformations. So take a second, pause the video, and read that part. Okay, welcome back. So dilations change the size of the object. And the thing that we reduce by is called a scale factor, and it means you're multiplying by it. So we're going to multiply, like again, it's multiplying by what the x and the y value by that number. So the formatting here is a little messed up. Number 8, this stuff should be here with this graph. So let's do 7 first. Dilate with a scale factor of 2 around the origin. Okay, so that means I'm going to take all these coordinates of these points and dilate by a scale factor of 2. So this point here, let's list them on the side. Looks like this point sort of went away. We'll call that point Y. That point is 0, 2. So Y prime means we're going to dilate by a scale factor of 2. That means we're going to multiply the x and the y by 2. If D is negative 1, 0, then d prime will be negative 2, 0. And then if z is 2, negative 1, then z prime will end up at 4, negative 2. So let's graph those points. 0, 4 is going to be my y prime. D prime will be negative 2, 0. And z prime will be 4, negative 2. That means we kind of expanded it out by the origin by a factor of 2. So you can see that things kind of, the lengths kind of double in all directions out from the origin. Again, you can see that there's like a line that goes through these vertices. And on that line, you've doubled the distance. Okay? So let's look at this guy. Again, there's these lines that all kind of go back to the origin, and they would all have the same scale factor. To me, it looks like a scale factor of 2 because the yellow one is 2, and then the long one is 4. The other ones I can't really tell what they are because they're on an angle, but it looks like they're doubled. It looks like this yellow one gets doubled to turn into that white one. So I'm going to guess that, because they're asking what the scale factor is, I'm going to guess that it's 2 just based on what I know about scale factors, dilations, and graphs. Let's see how we can figure it out exactly. What you can do is you can take A and A prime. Oh, I'm sorry, it got shorter. A is the pre-image, A prime is the translated image. So I'm going to say the scale factor is 1/2. It looks like they got cut in half. Sorry. Right, C prime is the shorter one. So it started at C and it looks like it got cut in half. So my guess is a scale factor of 1/2. Let's see how we can figure this out. The coordinates of A are negative 1, 1, 2, 3, negative 1, 4. Right, negative 1, 4. And then I can compare and see what's the scale factor of A prime, or what's the coordinates of A prime. Then I can figure out the scale factor. A prime looks like it's negative 1/2 and then up 2. Let's do that with B. There is no B. Let's do that with C. C is 1, 2, 3, 4, so it's negative 4, 0. And C prime seems to be negative 2, 0. And then K looks like it is 1, 2, 3, 4, 5, negative 5, up 3. And K prime translates to, it looks like negative 2.5, and then 1.5. So if I look at all of these, what number did I multiply by times what number to turn a 4 into a 2? To turn a negative 1 into a negative 1/2. What did I multiply by? To turn a negative 4 into a negative 2. What number did I multiply by? A 0 into a 0. Well, if I multiply 0 by anything, it stays 0, so that doesn't help. A 5 into a 2.5. So you can take any one of those examples and say 4 times what scale factor, I'll call it K, do I end up with 2? If it's not obvious to you that it's 1/2, you can set up an equation. You can take your pre-image coordinate times K, some number we don't know, which we're going to figure out, say equals your image coordinate, like where it ends up. Take your starting coordinate, your pre-image coordinate, multiply it by some scale factor K, and say it's going to equal the coordinate of the image where it ends up, and then you can take that equation and solve for K. So if I divide both sides by 4, I get 2 over 4, which is 1/2. That means the number that I'm multiplying by is 1/2, my scale factor. The last thing I'd point out here with dilations is if the number is 1, the scale factor is 1, it's not changing size at all, right? Anything times 1 keeps its size. If you multiply by a number bigger than 1, the image will get bigger than the pre-image. And if you multiply by a number less than 1, the image will be smaller than the pre-image. So that's what will happen there. Let's look at the next part. We're going to go through some composition. So pause the video. You can read this stuff right here. Okay, welcome back. So a composition is when we do two or more transformations are combined, and order is going to matter which ones you do. So remember that if we're doing more than one transformation, the final image may have many primes. In this case, there are two transformations. The first one produced A prime, B prime, C prime, and then the second one produces A double prime. So let's check this out, okay? Let's do number 9. Translate 1 unit left and 3 units up. So first we have a translation by the vector 1 unit left, so that's -1, and 3 units up. If you had me for geometry, we talked about these vectors. I believe you did in your other geometry classes as well, talk about vectors. So we're going to translate by that vector 1 unit left and 3 units up. So that's C prime, 1, 1, 2, 3. That's J prime, 1, 1, 2, 3. That's M prime, 1, 1, 2, 3. That's K prime. So that is my new image after one of the translations. Now I'm going to take, after one of the transformations, now I'm going to reflect over the y-axis. And that's going to produce my double primes. So J prime goes 1 unit to the other side to give me J double prime. C prime is 1, 2, 3, 4 units away from the y-axis, so I go 4 units away. M prime shows up over here to be M double prime. And then K prime is right on the axes, so on the line of reflection, so it stays where it is, and that would be K double prime. That would be K double prime. So let's do our final one in a different color. So in blue, this would be our final, after the composition, our final image. All right, let's see, what do we have left? 2 more. All right, let's reflect over x equals 2, then dilate by a scale factor of 2 around the origin. So first, if I reflect, or actually, let's do this. Let's graph these points first. A is 8, 2. B is 6, 5. And C is 7, -1. So that's A, B, and C. We get a triangle. All right, our first transformation is to reflect over the line x equals 2. So there's our line of reflection. So C is 1, 2, 3, 4, 5 units away. So I go 1, 2, 3, 4, 5 units away. And there's my C prime. A is going to be 1 further unit than that away. So it's a little bit further by 1. And then B is 1 short of that C prime. There we go. So there's our reflected shape over the line x equals 2. And then dilate by a scale factor of 2. So let's look at our new coordinates. A prime, B prime, and C prime became... A prime is now at 1, 2, 3, 4, -4, 2. B prime is now -2, 5. C prime is now 1, 2, -3, -1. Now we want to multiply by a factor of 2 about the origin. So let's get our A double prime, our B double prime, and our C double prime. It's easier to find the coordinates first. So if I multiply everything by 2, I get -8, 4, -4, 10, -6, -2. All right, so let's now go graph those. I'm going to graph those in a different color. I'll do those in blue. So -8, 4. There's our A double prime. -4, 10. There's our B double prime. And -6, 2. Sorry, -2. -6, -2. There's our C double prime. So you can see again, I like to show that when you do the scale factor, if it's back to the origin, you can see that that line passes through those vertices, and you can tell that the distance, since it was a scale factor of 2, has doubled on each one of those. So that's what it means to double around the origin. Let's get rid of those dotted lines. It's looking a little confusing. All right, let's move on to the last one, number 11. Describe the following composition of transformation. So we start at ABC. We do something to end up to, we do some type of transformation to get A prime, B prime, C prime. Then we do some other type of transformation to get to A double prime, B double prime, C double prime. That's going to be for you to do on your own. What 2 transformations do you think occurred in which order? And we'll talk about that to start class. Okay, thank you. And make sure you have everything written down so that you can get full credit on your homework. All this stuff that I wrote down. Thanks.